Good morning, everyone. We are going to go ahead and do a walkthrough for target 7.1, 7.2. I'm going to be really slow and methodical. I'm going to go through every last step. This is primarily for students who are really struggling with knowing what I'm looking for, knowing how to go through it. I've had many emails with students saying, I don't know how to do this. This would be a good place for you to start. So I'm going to go through this as slowly as I can. If you think you got it already, don't worry about watching this video. Just go ahead and check out the key that I'm going to post along with it. All right, so we're going to be looking at these two reactions today. I'll be trying to go fairly quickly, but still hitting on everything. So let's go ahead and start with reaction one. The very first thing I'm going to do is I'm going to underline all the things that are chemicals, all the names that are in here. So a solution of dissolved sodium hydroxide reacts with a solution of dissolved iron 2 chloride. This produces dissolved sodium chloride and a solid precipitate of iron 2 hydroxide. Those are the four chemicals that we have to work with. Those are the four chemicals that are going to have to end up in our formulas. So let's go ahead and write these out, figure out what these are. When I look up on my ion sheet, sodium is Na+, and hydroxide is OH-. So I know that I need just as many pluses as minuses, so one of these and one of these, that'll work. So I'm going to write this down here. One of these and one of these. Now notice they're stuck together now, so we don't see those pluses and minuses because the pluses and minuses balance each other out. It's only when they're separate that we can see them. We do need a state for this. So let's go back and look at the sentence and see if they tell us what state this is in. Is it solid, liquid, gas, or dissolved? A solution of dissolved sodium hydroxide. Oh, it tells us just right there. It says dissolved. So dissolved, the symbol we use for that is AQ. So right after this, I just go ahead and put AQ. All right, next, and let's switch colors here. So let's use solution of iron 2 chloride. So iron 2 is Fe2 plus, and chloride is Cl minus. So we need just as many pluses as minuses. So here I have 2 pluses, so I'm going to need 2 of those minuses. So when I write this out, it's going to be Fe. That's 1. This is 2 pluses. This is only 1 minus. So now we have 2 of those minuses. Again, it does say dissolved. So dissolved means aqueous. Now we're going to put these two together, and the symbol we use to say that we're being put together is plus, and then these two things are going to come together to make something else. That's what the arrow means. So we add these two together to make something else. All right, the things that we are making, we're going to make some sodium chloride, sodium, Na+, chloride, Cl minus, 1 plus, 1 minus, we're set. It tells us it's dissolved, so that'll be aqueous, AQ. So NaCl, AQ. And we're going to go ahead and put that together with iron 2 hydroxide. Iron 2 is Fe2 plus. It's a little smaller. Hydroxide is OH minus, and we want a solid, it says solid precipitate. So solid, the symbol we use is parentheses S. So we have 2 pluses, we're going to need 2 minuses. So here's our 2 pluses, and then we have to have 2 of those minuses. Now there's 1 minus, we need to have 2 of those. Now normally we just write a 2 right behind it, but we can't do that now because this just means 2 hydrogens. We need 2 of the entire thing, so we put parentheses around it. We do still need to tell everyone that it is solid. Okay, so that's the basic structure for how to write out the equation. Um, Next, we have to balance it. So it is not balanced, and here's how we know it's not balanced. See how there's only one, there's two chlorines right there? This 2 means that there's 2 of those chlorines. This only has 1 chlorine. There's only 1 chlorine on this side, so we need to fix that. If there's 2 chlorines over here, there needs to be 2 chlorines over here. So we can't just put a 2 there because that changes what we're talking about. And we don't want to change the chemical. We just need to change the number of those molecules, or formula units in this case. So the number of formula units in NaCl that you would need so that you have 2 chlorines is you would need 2 of them. Look, now I have 2 chlorines right here, and I have 2 NaCl's, and each NaCl has 1 chlorine. So that's 2 chlorines. But now we run into another problem, because now I have 2 sodiums, and over here I only have 1 sodium. So how are we going to fix that? Well, if we have 2 sodiums here, we need 2 sodiums to be over here. We can't just do that because that changes the molecule. I don't want to change the molecule. We're just going to need 2 of these molecules. Actually, that actually fixed a problem for us, because look over here. There's 2 hydroxides right here, right? Well, here there was only 1 hydroxide. We had to put the 2 here because that fixed our hydroxide problem. So I believe this is now balanced. We have the same number of atoms on both sides of the equations. The atoms that we draw out here can get rearranged into the atoms we draw out here. Here, let's go ahead and check. What I'm going to do is I'm going to go ahead and draw exactly what we have here as a particle picture. So we need 2 NaOHs. So that's an Na and that's an Na. That's an O, that's an O. By the way, the colors do not matter. You can use any colors you want. But this will be 2 NaOHs. All right. FeCl2. So here's what I'm going to do is I'm going to see if I can now take these things and redraw them over here on the right to make this stuff. So I need 2 NaCl's. So an Na is this yellow one, and a Cl is this green one, but I needed 2 of them. So what have I used? I've used 2 of these yellow ones. That's good, we're fine there. And I've used 2 of those green ones. That's good, we're fine there. All right, next, I need an FeOH2. Now, in FeOH2, there's an iron, that's the Fe part, and there's these OHs. But there's 2 of these OHs. That's what that means, 2 OHs. So there's an OH here and an OH here. Again, I don't care about the shape you're picking. I don't care about the colors or symbols that you're picking. What I care about is the right numbers of atoms in each molecule, the right numbers of atoms in each group. So let's just go ahead and count again one more time. 2 yellows, 2 yellows. Those are sodiums. 2 oxygens, the reds. 2 oxygens. We're good there. 2 hydrogens, 2 hydrogens. 1 iron, the blue one. 1 iron, the blue one. 2 chlorines, 2 chlorines. Yeah, this is now balanced. We have the same number of atoms on both sides of this equation. I think this is set. If you were to turn this into me right now, it would be totally good, totally correct. All right. So do be aware, I have to be able to see these things. So I'm going to point out a few notes. You wouldn't turn in these notes, but I'm just going to really point them out. I'll put all of my notes in this kind of pink color so you can kind of tell. See how it says there's 2 molecules right there? That's what that means. There's 2 of these NaOHs. I need to see 2 separate things. I've had a lot of students who are putting these all together into one clump, right? I've had a lot of students who are showing me something like this. And that's not okay. We need them to be separate. Similarly, I've had students showing me things that are separate that shouldn't be, right? Right? Let's see if I can do this. I've had students showing me, um, oh, that's not attached. And um, right, they've been showing these all separate. I don't want to see them separate. I want to see them together. They're all together here in the molecule. They should be all together here in the drawing. All right. So that's really important to me in a large number. I've had a lot of students who that's the thing that's holding them back is the way that they're grouping these atoms. All right, one more. This one's a pretty simple one. Let's try this one out as well. Solid phosphorus. So phosphorus, we'll make pink here. Oxygen will make kind of a green. Ugh. Make it yellow, I guess. Phosphorus reacts with oxygen gas to produce solid diphosphorus pentoxide. All right, diphosphorus pentoxide. So we got three chemicals there. The phosphorus here, if I just look up on the periodic table, it's an element. It's just P. That's it. It's not a Hofbrinkel, so it's not P2. Only Hofbrinkels always have that 2 there when they're elements. This phosphorus right here is just a good old P. Now we are told that as a solid, so I'll just go ahead and put a little S back here. Oxygen's also an element, so I'll just draw O. But this one is a Hofbrinkel. So oxygen never shows up as a single atom by itself. It's always with something else. Even if it's by itself, it'll just be 2 of those same atoms. So it is also a gas. So a lot of students have been missing out on the Hofbrinkel stuff. So this is a perfect case for you to really see the difference. A Hofbrinkel is something that when they are a pure element has to be 2 of them stuck together. Something that's not a Hofbrinkel, like phosphorus here, doesn't. All right, so we're going to put these 2 things together and we're going to make diphosphorus pentoxide. So diphosphorus pentoxide, obviously it's got these little prefixes here. We can do prefixes. Di means 2 phosphorus. Pentaoxide, 5 oxygens. Now, these are all stuck together into one molecule. That's why that's the name, diphosphorus pentaoxide. So this is all just one big molecule, and we are told that it is a solid. I will admit, in real life, I actually don't know what state of matter it is, so I just mentioned that it was a solid, but I could be wrong there. All right, so these 2 things are going to become this. So we are going to balance this one, but this time I'm actually going to balance it differently. Instead of starting off by just looking at the symbols, I'm going to start off by I'm going to draw it. I just think it's easier for one like this. So here's what I'm going to do. I'm going to draw one of each. So O2. This one has 5 O's. Phosphorus. We'll go ahead and make this sort of yellow color, orange color. And this one has 2 of those phosphoruses. So let's think about this. This is obviously not going to work, right? Because I only have 1 phosphorus here. I have 2 over here. So we definitely need at least another phosphorus. But the oxygens are going to be a problem because I have 2 oxygens here. There's 5 here. So if I start adding more oxygens, we pretty quickly overshoot 5. So that's not going to work. So we're going to need to make more than one of these. There's no way I can use oxygens to make a P2O5, just to make one P2O5. We're going to have to make another one. So I'm going to go ahead and just make another one of these guys. So now let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 oxygens. I can get 10 oxygens though. look, now there's 10 oxygen atoms. So those 10 oxygen atoms can make two P2O5s. Now, as far as the phosphorus goes, there's 1, 2, 3, 4 phosphorus. Let's just go ahead and add those. And now we're all set. I'm pretty sure this is balanced now. 1, 2, 3, 4 phosphorus, 1, 2, 3, 4 phosphorus. 2, 4, 6, 8, 10 oxygens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygens. This is balanced. So let's go back and count what we had to use. I had to use 4 phosphoruses. I had to use 1, 2, 3, 4, 5 oxygens. And I ended up making 2 of these P2O5s. You're welcome to go through this process whichever way makes more sense to you. If you'd like to use the symbols to go ahead and get the balance, that's great. Ultimately, that's where you'll probably end up once you get competent at this. But that said, I have students who draw this out forever. I literally have received scratch paper on tests that is just pages and pages of people drawing little circles. It's a little slower, but if that's what makes sense to you, fine. All right, everyone. I'm hoping that this answered questions that you may have. I'm hoping that these are good examples. If you ever get stuck on how to do this again, feel free to watch the video again. Save it to your reference. And yeah, let me know if you need me for anything. All right, everyone. Have a nice day.